Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 3.4 from the C Programming Language textbook by Kernighan and Ritchie. Now exercise 3.4 says, in a 2's complement number representation, our version of I to A does not handle the largest negative number. That is, the value of n equal to negative 2 to the power of word size minus 1. Explain why not, modify it to print the value correctly regardless of the machine on which it runs. Now this is the itoa function. It's the current implementation that's given in the book. I've just copied it out. This is the reverse function. Once again, I've just copied it out. And here I have a program just testing itoa. So just to show that it works properly, I'm going to compile it and run it. And we expect that string that we just saw in the print to be printed out. There we go, 390153. And as you can see here, we have 390153. Now, what if, and I've done this beforehand, on my system, the largest possible negative integer or negative number is this. And the program says that it is not able to convert this. So let me just try that and let's just double check. And it's pretty obvious there that it doesn't. And just to make sure that this is really true, what if I just change this to be one number less? Will it work now? Yes, it does. So clearly we're running into a problem. Now the question is, what is this problem? I'm just going to delete this comment. No, I'll leave it. Right, what is this problem? Well, the problem is here. Well, actually, let's just talk about 2's complement number representations. You know, say my system actually has integers represented with 4 bytes or 32 bits. But for example's sake, say we're working with a system that has integers as 8 bits, just to keep things simple. Well, if it's 8 bits in a 2's complement number representation, the numbers can be represented between negative 128 all the way up to 127. So in 8 bits, the largest possible number is 128 and 127, and the smallest possible number is negative 128. So when we get here to this line, and I see that I have a negative number and I want to turn it positive, well, what I'm doing is I'm taking negative 128 and I'm trying to turn it into positive 128. But the problem is, in 2's complement, I can't do that. I can only represent the biggest possible number as 127. So that's where my issue is arising. So we need to work around this. And because of that, we should get rid of this. Now the question is, if we get rid of that, how are we going to change our program? Well, here we need to do something smart. Because if I have a negative number, say I have a negative 34, I take negative 34 modulo 10, that becomes negative 4. I don't want to do the character 0 minus 4, right? So I should take the absolute value, and this is a function that's defined in standard lib, I believe, right? So what I do is I take the absolute value and say, for example, once again, say I have negative 34. Negative 34 divided by 10 is negative 4. Negative 4 absolute value becomes 4. And then 4 plus the character 0 is the character 4. So we get that 4 at the end of negative 34. But then this while condition needs to change as well. Because if I have a negative number and I say, well, this is larger than 0, negative 34 divided by 10 is negative 3.4. We truncate the floating point, so we just get negative 3. Negative 3 is obviously not larger than 0, so we break out of here. But I don't want to break out. I want to stay there and then convert the 3, you know? So I shouldn't do that. Do I then do this, is the question? Well, now, if I pass in a positive number, I'm also going to break out prematurely. So actually, the best possible solution is this. I'm going to keep on dividing while I'm not at 0. So while there is still something left to put in the string s. And now, the rest is pretty simple. This can stay. If the sign is less than 0, we assign that, and we can reverse the string. So let's see if we get this printed out this time. This number here. Let's try it. And look at that. Now it prints out just fine. And just to make sure that it still handles other cases as well, let's just take a positive number, 83648, and here we have 83648. So that's how we can write the itoa function to handle negative numbers properly, and even the largest possible negative numbers. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.